So we can do more with slope as well. We can actually use slope to graph. So here's a third way that you can graph. This is particular to just lines though. So we can use intercepts with curves as well. We would still need more than 2 points though. So anytime you have a curve, 2 points is never going to be enough. You need lots of points to see the pattern for curves. Typically speaking, unless you're comfortable with the shape of it already, because you've worked with it for a while, that's different. But in general, if you're graphing a curve, you need lots of points. If you're graphing a line, you'll need 2 points. So we can still use intercepts to help us look at curves and graphs and things like that. But when it comes to graphing with slope, this is really just for lines. But it's a nice little application here. It makes graphing pretty fast. So there's a form of the line called the slope-intercept form of the equation. And there's lots of different forms of linear equations. This is just one of them. And in this form, your slope is m, and your y-intercept, we're using the label of b. And we write it like this. So it's still a linear equation, right? Because your x and your y don't have any squares or cubes or anything going on. So it's just a linear equation. It's just in a form where y is by itself. Y has been solved for. We can still use function notation here because all lines except for vertical lines are functions. And we can also use this notation, but both of them basically mean the same thing. You have some sort of line and your m is slope and your b is specifically the y-intercept. So you have the point 0b. Now we can graph a function using the slope-intercept form quickly. And what we do is we first plot that y-intercept on our graph. And then we use the slope to find the next point. And we do it by counting the rise and the run. So in our example here, our slope is 2/3. So your slope is always the value with the x when you're in the y equals form. And remember that top is the vertical change and the bottom is the horizontal change. So we're going up and down vertically 2. For every 3, we go horizontally across here. So let's go ahead and graph this. So again, before we even go there, let's just do a little bit of review. So your slope is always going to be with the x when we are solved for y. So that is the key though. You cannot pick out the slope in other forms. So if I had an example that was like 4x plus 2y equals 6, 4 is not the slope. This trick only works if the y is by itself. So you do need to be careful. And then the other piece that's not with the x is your b. So our y-intercept is the point 0b. So for our example here, we have our slope is 2/3 and our b is 2. So the first thing I'm going to do is start by graphing that y-intercept. So I'm going to graph the 0, 2. And that's always going to be my first point. And then from there, I'm going to use the slope. Now, I want to notice a few things. First of all, I'm noticing here that my slope is positive, right? So it's positive 2/3. So if I have a positive slope, my line should be increasing, going up from left to right. So I'm going to keep that in mind when I'm counting. And then my vertical change is going to be 2, and my horizontal change is going to be 3. So what this is going to mean, I'm going to start here. Actually, let's use a different color. I'm going to start at my point that's already here, and I'm going to go up 2 and over 3. So up 2 over 3. And again, I want this to be increasing. So what I'm going to do is I'm going to go up 2, and then I'm going to go 3 to the right to get my next point. Now, that's actually sufficient, but you could keep doing that pattern over and over again. So I could go up 2 again and over 3 the next time. So you could use this to do as many points as you want to get those values. Now, you can also reverse it. So let's say you want some more points, but you want them this way. Just keep in mind that you want an increasing line overall. So I can work backwards. Instead of going up 2, I can go down 2. But instead of going right, I go left. So 1, 2, 3. So you can still do that same kind of pattern in both directions. And then I can just take out my straight edge and draw my line. So if your slope is positive, then when you're counting, you're either going to go up to the right or you're going to count down to the left. So that's kind of like the backwards direction, right? So normally we go up to the right, but if you need to work backwards, just go opposite. If your slope is negative, then when you count, you're going to go down to the right, or you're going to go up to the left because you want to have that nice decreasing line instead. Let's do another example. So here again, we're going to graph the linear function using the slope and y-intercept. It's not in the right form though, so I do have a hint here. Solve the equation for y first to put it in the form y equals mx plus b. So if you're going to use the slope and the y-intercept, you need to make sure that you solve for y. If it's not already done, like in our last example, the y was already by itself. Here it's not, so I do need to solve for y first. So think of this as solving for a formula, right? So we want to get that y by itself. So I'm going to get rid of everything else. The first thing I'm going to do is take this 2x, move it to the other side. So I'm going to subtract that 2x from both sides. Now, you don't really need the 0, but if you want to keep it, you can. If you want to put it in, it'd be plus 0. And then we're going to get rid of this 5 by dividing by both sides. And just be careful when you divide, technically you're dividing both parts. So I have negative 2/5 x plus 0, or just negative 2/5 x, because again, we don't really need that plus 0. Now my y is by itself, so I can pick up my values. So your slope is always with the x. Okay, so our slope here is negative 2/5. Now your b, in this case, so if you kept the 0, it's pretty easy to see that your b is 0. If you didn't keep it, it's okay. Keep in mind if there's no plus or minus, then your b value is going to be 0. So our point then is going to be 0, 0 that we're going to start with. Now my graph, or sorry, my slope is negative, so I want to make sure my graph is going to be decreasing. So when I count, I'm going to go down to the right. Now I have a negative 2/5, so I'm going to go down to right 5. So down 1, 2, right 5. 1, 2, 3, 4, 5. Down 2, right 5. Now, if you want some points over here, we can still do that same idea, but you work backwards. Instead of going down 2, you go up 2, but instead of going right, you go left. Right, so you're still getting that same kind of decreasing idea, but to get points on the other side, you have to think about it in the backwards direction. I do recommend when you're graphing using slope and y-intercept just to check your overall direction of the line at the end when you're done. My line is going down, so it should be a negative slope, which it is. Here, my line is going up, and it should be a positive slope, which it is. So it's not a perfect check, but that at least assures that you went in the right direction. So I just want to point out that we've actually seen 3 different ways that we can graph. So we've seen the plotting points method, which we learned back in 7.1. Now that plotting points method works for anything. It works for lines, it works for curves. You can find as many points as you need to just by picking values to plug in. We also talked about today the intercepts method, where you pick specifically those zeros to plug in and get the points on the axes. Now you can find intercepts on curves as well. You'll need more than just those 2 intercepts though, or just those couple of intercepts. You can, with curves, they can actually have more than one intercept in either direction. But for lines, if you have 2 different intercepts, then that's enough to actually graph. And then we talk about another method called slope-intercept method for lines specifically. So that is a way that you can graph with lines. Now, there's one more thing in graphing I want to talk about, and that's how do you graph horizontal or vertical lines, because we haven't seen those yet. Now, your horizontal lines, which go like this, always have equations that look like y equals a number. Your vertical lines, which go like this, always have equations that look like x equals a number. So here are our 2 examples. So y equals -4. So what you're going to do is find -4 on the y-axis. So this is actually your y-intercept. And then you're just going to draw a horizontal line right through it. So when it's y equals, it's a horizontal line. So I'm going to go like this. Now, if you're in MyMathLab, what you can do is just plot your intercept first, and then click any point to the right or left of it, and it will make a nice horizontal line for you. For the other one, see how you have x equals? So you're going to plot the 2 on the x-axis, because this is actually your x-intercept, 2, 0. And then your x equals is always a vertical line, so you're just going to graph that straight up and down. And again, in MyMathLab, if you need to, because you do need at least 2 points to graph in MyMathLab, just pick any other point directly above or below, and that will make that nice line for you. One little side note here, sometimes you may see an example that could look like this. Maybe I gave it to you as y plus 4 equals 0 instead. Hopefully, though, you recognize that there's no x. So if I solve for y here, I do get that same form of y equals -4. So just watch out for those. We don't see them too often, but once in a while you may see something like this. But if you're graphing in 2 dimensions here, so in 2 variables, then what you can do is just solve and then find your intercept that way.